Alright, today we're going to go over common log equations where now we've got quadratics inside. Now really it works the same way as common log equations with linear, it's just that now we're having to solve a quadratic equation. Good thing that we just did that. So here we notice they both have base 11, so I can go ahead and set 5n plus 2 equals to n squared minus 4. And I know that I'm going to want to go ahead and set this equal to 0, and that my life is easier if the squared term is already positive. So let's go ahead and subtract over the 5n and subtract over the 2. Subtracting over the 2 combines with the 4. The 5n does not have a like term. So then I get 0 equals n squared minus 5n, because there's nothing for that to combine with, minus 6. Now I have something that's easily factorable because I know that I'm going to have an n and an n. I need to multiply to negative 6 and add to negative 5. So then I know that I can use negative 6 plus 1. And then am I quite done yet? Not quite. I've got to go ahead and set n minus 6 equals 0, n plus 1 equals 0. Add 6, minus 1, cancel. I get n equals 6 and n equals negative 1. Now I've got to determine which of these is the solution that I want to go with, because it's not going to be both. It actually will have sometimes just one solution. What we've got to do is check as if it's valid when I plug into this. So if I get 5 times 6 plus 2 and 6 squared minus 4, plugging into 5n plus 2 and n squared minus 4, I've got to make sure both of these need to be positive, because it's not possible for me to take an exponent in this case and get a negative solution. So I've got to get a positive solution. So I go ahead and check. I get 32 and I get 32 again. These both equal each other and they're both positive solutions. Now if I plug in negative 1 into both of these, negative 1 squared minus 4, again we're plugging into 5n plus 2 and n squared minus 4, then I get negative 5 plus 2, that's a negative 3. We get 1 minus 4, that's a negative 3. That's negative. The negative 1 is not a valid solution. So after you solve, you need to check, is it valid? So my solution is just n equals 6 in this case. Alright, let me re-go over the steps, then I'm going to show you another example. So first, you go ahead and set both sides equal to each other. If I was taking notes, I would definitely write this down. If I'm just planning to take a picture, then I would wait till I'm done writing the steps, pause the video, take a picture. Then, solve like a normal quadratic. This can either be by factoring or the quadratic formula. Either way is fine. In fact, in some cases, you might only be able to use the quadratic formula if it doesn't factor nicely. Then you need to check if it is valid. That means it has to be positive when you plug into the log. So go and take a picture of that, write that down, whatever you need to do. Those are the basic steps I gotta follow. So let's do another example. Let's say I had log base 3 of 10k plus 3 equals log base 3 of k squared plus 3. So let's go ahead and solve this guy out. I want you to go ahead and pause the video. I want you to go ahead and try this on your own before I go through it. Alright, welcome back. We're going to go ahead and set 10k plus 3 equal to k squared plus 3. I can go ahead and subtract over the 3, subtract over the 10k, subtract over the 3, subtract over the 10k. I get 0 equals k squared minus 10k plus 0, because the 3 and the negative 3 again cancel. So then if I want to rewrite it without that 0, that's fine. Do these have a like term? Absolutely. That like term is k. And now I can go ahead and just set each equal to 0. I get k equals 0 and k minus 10 equals 0. So then I get k equals 0 and k equals 10. So let's go ahead and plug these guys in to make sure that they are valid solutions. Let's check k equals 0 first. So then I get 10 times 0 plus 3. That's 3, that's fine. And then we get 0 squared plus 3. That's 3, that's fine. Now, if you solved it right, you should get the same solution twice. It should both be positive and should both be the same thing. If you're not getting the same thing, then you did something wrong. So then we can check k equals 10. Is 10 times 10 plus 3 a positive? Absolutely. Is 10 squared plus 3 a positive? Absolutely. And I got the same thing both times, so I know I did it correctly. Alright, for those that want another example, I'll go ahead and do another one with you. If you want to just move on to the practice, that is a-okay too. Alright, let's do another one. Let's try log 13, 28 minus 3m equals log 13 m squared. Now you'll notice I'm always giving you things that have common log bases because that's what we're working on. If you encounter this in the wild, make sure that you have common bases before you go ahead and start setting things equal to each other. So let's go ahead and set 28 minus 3m equals m squared. Go ahead and subtract over 28, add over 3m, subtract 28, add 3m. Nothing to combine anything with. I just get 0 equals m squared plus 3m minus 28. Well, let's go ahead and start setting up our factoring. So we're asking ourselves what multiplies to negative 28 and adds to 3. I'm already thinking I want to use the pair 7 and 4. My 7's got to be positive and my 4's got to be negative in order to make it add up to 3. I set m plus 7 equals 0, m minus 4 equals 0. Subtract 7, subtract 7. M equals negative 7, add 4, m equals 4. And I'm good to go. Now let's go ahead and plug these guys in to check if they work. So let's check m equals negative 7 first. So I get 28 minus 3 times negative 7. That's going to give me 28 plus 21. That equals 49 and is positive. If I take negative 7 and square it, that's 49 and it is positive. If I check m equals 4, I get 28 minus 3 times 4. It's 28 minus 12, which will give me 1 and 6, 16. And then we go ahead and take 4 squared. Again, that'll give me 16. I'm good in both cases. Both of them are valid solutions. If you want a refresher about quadratic formula, remember that's x is the opposite of b, plus or minus square root b squared minus 4ac all over 2a. So if you ever have to solve something with quadratic formula, there's also videos under the previous unit that you can go refresh quadratic formula with. Most likely, most of these will be solvable just by factoring, but just know quadratic formula is indeed another tool in your toolbox. Alright, I hope this was helpful. Please continue to reach out to me if you have questions. Have a wonderful day.